Hello, here's another AQA A-level physics question on simple harmonic motion. If you want to try to answer the question yourself, pause the video now. If you got the answer D, well done. Okay, so the graph shows how the displacement of a particle performing simple harmonic motion varies with time. Which statement is not correct? And there's lots of statements about speed, potential energy, acceleration, and restoring forces. So let's have a look. I'm going to answer this by drawing additional graphs, or explain this question by drawing additional graphs on here. So one thing we know is that velocity is equal to the rate of change of displacement with time. So I could add on to this graph, I could show how the velocity changes with time. And the velocity is literally going to be the gradient of this graph. So when the gradient is 0, my velocity is 0. When the gradient is maximum negative, my velocity is maximum negative. So you can go through this and we should get a graph that looks like that. Hopefully you can draw a bit neater with a pen and paper. Now I'm going to change colours because acceleration is equal to the rate of change of velocity with time. So again, if I just look at the gradient of the velocity time graph, I can find the acceleration. And when the gradient is maximum negative for the velocity time, it means the acceleration must be maximum negative. And I'll get an acceleration graph that looks like that. Okay, so let's have a look at these statements. The speed of the particle is at a maximum at t over 4. So here's t over 4. Is the speed at a maximum when it's t over 4? We can have a look at the velocity time graph and we can see yes, the speed is at a maximum at t over 4. Remember, we're looking for a not correct statement, so that's a true statement there. The potential energy of the particle is 0 at 3 over 4t. So there's 3 over 4t. So the potential energy will be 0 when the displacement is 0. So let's have a look at the displacement. That's the black line, and at 3 over 4 we can see the displacement is at 0. So the potential energy will be 0. So that's true as well. The acceleration of a particle is at a maximum at t over 2. Let's have a look at t over 2. We're looking again at the acceleration graph. No, we can see the acceleration, that is at a maximum at t over 2. So that's another true statement. The restoring force acting on the particle is 0 at time t. Well, at time t, we can see the acceleration is at a maximum negative. Don't worry about the sign, it's just telling you which direction it's in. So the acceleration is a maximum when at time t. And we know from good old force equals mass times acceleration that the acceleration is proportional to the force. So if the acceleration is at a maximum at time t, the force must be at maximum at time t. So that is an incorrect statement, a false statement. So the answer you're after is D. I hope this was useful. If it was, like, subscribe and share please, and watch more of them in the series.